Night arrives like a silk curtain, and the world softens. Street lamps paint quiet halos on damp stone, and windows glow like held breath. Above it all, the sky spreads a dark ocean where light travels with tireless patience. In that silent expanse, gravity holds its own counsel, invisible yet persuasive. The two seem so different. One can be seen by the eye, gathered by a lens, measured by a sensor. The other is known by its pull, inferred from orbits, felt in the weight of a hand on a table. Yet every gentle star that appears is a messenger carried by light, and every path that messenger takes has been chosen by gravity. Together they form a lullaby of the universe, a song of straight lines that turn and clocks that soften, a music that asks for nothing more than attention. There is no hurry in this music. Light will keep moving, and gravity will keep curving the stage beneath it. The listener only needs to breathe and let the calm arrangement reveal itself, note by note. In this quiet, one small realization drifts forward. Relaxation can be a form of understanding. When a mind loosens its grip, patterns emerge. A ray, a ripple, a falling apple, a circling moon, a distant glow that left its source before oceans formed. All are verses in one patient poem. Light traces the shape of reality, gravity writes the grammar, and the night offers a page wide enough for both. He sits on a hillside path, or she stands by a kitchen window at midnight, and the same truth draws near. Light is motion that has no rest frame, a signal that outruns all other messages. Gravity is geometry that refuses to be flat, a presence that tells masses how to move and tells light how to aim. Even without equations, the mind can lean into this. A beam from a candle does not tire. It does not slow, and it does not speed. It holds a constant pace that defines the very idea of speed. In that constancy lies comfort. A constant is a tether in the dark. Gravity offers a different comfort. It is the promise that things belong to one another, that paths are not careless, that curves are meaningful. In the quiet hours, the two together feel like kindness. One is guidance, one is companionship. Consider a single photon leaving the surface of a star. It steps into cold space with no mass and all intention. It carries energy, momentum, and a tiny packet of information about where it came from. It moves in a straight line, but the meaning of straight is not what a ruler claims. Straight is whatever path a free thing follows when nothing pushes on it. Gravity does not push, not in the ordinary sense. It reshapes the stage, then invites the traveler to keep doing what it would have done anyway. The photon obeys, without force, without complaint. It arcs through a curve that is also a straightness, and this paradox lands like a warm blanket on a winter chair. The world can be more than one thing at once, and still be a refuge. The calm deepens when the idea of time joins the scene. He imagines a clock made from light, a single pulse bouncing between two mirrors. Each bounce is a tick. If those mirrors sit near a heavy mass, the ticks separate a little more. The clock does not break. It stretches its rhythm to match the ground beneath it. To call this slowing a flaw would be to misunderstand the grace of adaptation. Time yields where it must, and in that yielding, the universe stays whole. She imagines two such clocks, one on a mountain, one by the sea. The mountain clock, farther from the center of Earth, runs a hint faster, a tiny kindness offered by thinner gravity. Everyday life does not notice, but the cosmos does, and precision instruments agree. The difference is small, yet the idea is large, and largeness can be restful when it carries no threat. The mind drifts to the horizon where the dark thickens and stars organize themselves into a faint river. Light from those stars has crossed distances beyond language. It threads through the invisible sculpture of gravity carved by dust, planets, and galaxies. That sculpture is not static. It is a quiet dance of masses, a choreography that moves too slowly for a single lifetime to see. Even so, the photon keeps faith with the stage, gliding along the nearest definition of straightness available. The result is a picture that reaches the eye with subtle edits imposed by the journey. A star lies where it appears, and yet it also lies where its light has been guided to appear. The mind can hold both truths at once. Holding both is restful as well. In the hush of this recognition, a thought settles in. The peace of the night does not come from silence alone. It also comes from predictability. Light holds to a rule that is not negotiable. Gravity holds to equations that can surprise but do not betray. The surprise lives in the shapes, not in the ethics of the world. A river twists, but it still runs downhill. A ray bends, but it still points along the path of least resistance that geometry provides. The listener can let expectations relax while trust remains. It is a rare mix, and it is generous. He watches a satellite slide across the sky, bright for a minute, then gone. Its path is a compromise between speed and the planet beneath it. Gravity is not a chain. It is permission given to motion to find a circle, or an ellipse, or a gentle fall. Light from the satellite arrives a fraction of a second after it leaves, a delay that hardly matters, and yet matters completely, because the delay contains the fundamental story. Nothing moves faster, nothing pierces the limit. In that limit, quiet safety appears. The universe has boundaries that foster coherence, and coherence is a refuge. She thinks of a prism on a shelf, how it splits daylight into a little rain of color. Gravity has no color, yet it can tint time and shift the pitch of light. Even here, the effect can be soothing. A deep well of gravity can stretch a frequency toward red, like a cello note sliding to a lower register. The melody is the same, only calmer in tone. From the surface of a dense star, a photon leaves with a particular blue, then arrives with a deeper red, not because the light has lost its resolve, but because time itself has asked it to pace differently. To accept that request is to remain in harmony with the stage. It helps to picture space not as a void, but as a fabric that can carry both a pulse and a bend. Light is the pulse. Gravity is the bend. A pulse on a drumhead can travel for a while, reshaped by the tension and the curves it meets, still recognizably itself. The listener does not need the drum to be perfect. Small ripples add character, not confusion. The same is true for the sky. Imperfections are stories, not mistakes. A beam that detours around a cluster of galaxies creates a mirrored arc, a delicate repetition, a visual lullaby written across millions of light years. The eye welcomes it because repetition eases the mind, and because the arc still points to one source, a quiet reminder that guidance endures. The hour grows deeper, and one more idea lands with a feather touch. There is no need to choose between light and gravity. One is not the opposite of the other. The two cooperate, and cooperation is restful to witness. Energy carries information about events. Curvature carries instructions about routes. Between the two, a message can leave a star and find a retina, a sensor, a telescope tray, dusted with frost. The receiver breathes and finds that understanding does not always require effort. Sometimes it requires only receptivity, the willingness to be a shore where gentle waves arrive and dissolve. If a question forms, it can be a soft one. How does the world remain so consistent across such gulfs, across such spans of time, across so many shifts in scale? The answer is patient. Light remains constant in speed, even when the path is not straight in the Euclidean sense. Gravity remains the author of curves, even when no mass presses or pulls. The two meet, and the result is tenderness. A traveler and a guide, neither superior, both essential. To notice this is to be allowed to rest, as if the cosmos had placed a hand on a shoulder and said that care has been taken with the details. The last street lamp blinks out, and the hillside cools. He closes his eyes. She lets the window darken. The sky continues its quiet work. Photons from the day have gone, and photons from ancient nights keep arriving. The stage holds, the roots persist, and every arrival is a small promise kept. This is the most relaxing fact of all. The universe is vast, yet its most subtle agreements are honored. Light will not forget the pace it chose. Gravity will not forget the shape it writes. Nothing needs to be forced. Awareness and a little stillness are enough for the melody to be heard. Dawn had not yet broken on the island of Principe when crates were pried open and lenses breathed the wet air. In a clearing ringed by palm and the slow murmur of insects, a small team raised a metal skeleton toward the sky. Across an ocean at Sobral in Brazil, another team did the same. The date was the 29th of May, 1919. Totality would arrive near noon, a brief gift of darkness when the sun would hide and a necklace of stars would become visible next to its blackened disk. Those stars, members of the Hyades, would serve as the quiet rulers of a cosmic experiment. If their starlight appeared shifted during the eclipse, a prediction would be vindicated, and the curve of space would have found its instrument. Arthur Eddington walked the damp ground in Principe and listened for the subtle complaints of gears settling into alignment. He was a Quaker and a mathematician with a patient manner, someone who could hold a fragile possibility in his hands without squeezing it too hard. The eclipse was not just a celestial event to him, it was a test written in the sky for a new idea about gravity. He and his colleagues had planned for months. The path of totality had been traced, shipping routes checked, permissions negotiated, timing rehearsed again and again. Nothing seemed trivial. A lens slightly out of focus would blur the truth. A cloud crossing the sun at the wrong moment would erase it. At Sobral, Andrew Crommelin and Charles Davidson oversaw a set of astrographic telescopes and a 6-inch lens that had been coaxed from observatory life into the heat of the Brazilian plains. The atmosphere shimmered. The metal creaked as temperatures rose. The men kept a shade when they could, then returned to the instruments to check settings and ground their anticipation in routine. Everything led towards 6 minutes of darkness. Within that brief curtain, the bright points near the sun would be photographed. Weeks earlier, comparison plates of the same region of sky had been taken at night when the sun was in another part of the heavens. Those plates would later be laid alongside the eclipse plates. Shifts in stellar positions would tell the story. The method was elegant in its restraint. No grand machines tore at the sky. The Earth, Moon, and Sun provided the arrangement. The researchers brought careful optics, plates sensitive to light, and an agreement about how to measure faint impressions against a field of coordinates. If gravity did not affect light, the apparent positions of the Hyades stars during totality would match the comparison plates. If gravity did affect light, the stars would appear displaced away from the sun by a small angle. A prediction existed for how large the displacement should be, one that pointed not to a force dragging light, but to the geometry of the world itself. That number, near 1 3/4 arcseconds at the solar limb, was tiny. The eye could not notice it. A ruler on a desk could not notice it. A thoughtful instrument might. Morning unfolded with tropical caprice on Principe. Clouds gathered and drifted. Eddington watched the sky tighten, then loosen. The clearing seemed to breathe. Mosquitoes whined near sleeves rolled up past the elbow. The camera obscura of the natural world was getting ready. Totality approached. The air took on a strangely intimate quality that often accompanies a great eclipse, as if sound had been muffled by velvet. Shadows grew sharp, then softened. The last bright sliver of the sun vanished behind the moon. For a few minutes, day transformed into a night with a crown. The corona stretched like white petals and the stars near the black circle lifted their faint faces. Shutter cables were pulled. Plates slid in and out. Timing was everything, and so was steadiness. Eddington and his assistant captured what the sky briefly allowed. Then the light returned, gradual at first, then with full conviction. In Sobral, the team had enjoyed clearer skies, though a swell of heat had nudged one telescope out of perfect focus. They had secured multiple plates from 2 instruments, enough to trust that at least some would hold precise images. The drama of collection yielded to the quietness of analysis. Wooden crates crossed the ocean. Laboratories received them with caution and care. Glass plates were cleaned of dust, labeled, placed on measuring machines. The work of comparison demanded patience. Microscopes traced the position of each star on each plate. Corrections for systematic distortions were computed. Plate constants were derived. The goal was all but invisible to the naked eye, yet it could be resolved by a ledger of numbers and a careful hand. The result that emerged did not shout. It spoke in tenths of arcseconds, in error bars, in cautious averages that tried to be fair to the difficulty of the conditions. 2 instruments at Sobral disagreed in their clarity. The astrographic images, disturbed by thermal effects, suggested a smaller deflection and were treated with skepticism. The 6-inch lens provided cleaner stellar points, closer to the predicted shift. Plates from Principe were few because of cloud, but the best of them pointed toward the same neighborhood of values. The outcome was not a triumphal banner. It was a weighted sum of delicate data. When announced, it altered the status of a theory that had spent years as a bold sketch. The measured bending of starlight near the sun did not vanish into noise. It was present at a value consistent with a geometry that replaced the old idea of gravity as a force in a fixed stage. The human scene was quiet and memorable. In a London hall that November, the result was described to an audience trained to distrust spectacle. The matter of stars shifting near a black sun by less than 2 arcseconds could have seemed a fussy detail. Instead, it felt like a door opening. Newspapers found words that reached across breakfast tables. Lives went on, but something in the intellectual air changed temperature. A quarrel between straight lines and curved spaces had been resolved in favor of a subtler understanding. Light, though without mass, did not ignore gravity. It attended to the shape of space-time and traced the nearest available straightness within that shape. The eclipse had exposed this behavior with a kind of ceremonial clarity. There were, of course, objections and revisitations. Data would be re-examined in later years, other eclipses would be measured. Radio astronomy would offer more precise tests when the sun passed near bright sources far beyond the Milky Way. Spacecraft would later deflect signals around planets and confirm delays and bends to greater accuracies. Yet the 1919 expedition held a special calm in the memory of science. It was the moment when a suggestion became an observed fact, when a principle stepped onto the physical stage and bowed under the light of the sky itself. What made the event especially soothing was its reliance on patience and timing rather than force. No laboratory imposed conditions on nature. Nature offered the conditions. A new moon stepped between Earth and Sunday. The corona wrote filigree on darkness. Stars offered their faint points as a measuring stick. People watched and recorded. The truth emerged at human scale from a cosmos far beyond human size. It was the science of listening more than speaking, of attending more than insisting. The story also carried a quiet moral about cooperation. Observatories coordinated across continents. Sailors moved instruments across waters that did not care what was in their holds. Local workers helped raise platforms and shelters against rain and glare. Scientists accepted that some of their plates would be failures and that some of their hopes would be clouds. They prepared enough redundancy to make grace likely, not guaranteed. The result was a blend of courage and humility. Courage to go and wait. Humility to let the sky decide. When the numbers were finally set to paper, they did not just support a new account of gravity. They offered a way to see the universe with more gentleness. If a star's light could be nudged by the sun's presence, then space was not a rigid corridor. It was responsive. It could be shaped by mass and energy, and within that shape, light would remain loyal to its constant speed while accepting a revised path. This flexibility had room for serenity. Straightness did not need to be stubborn. It could be faithful and adaptable at once. In that sense, the eclipse of 1919 granted the world not only a result, but a manner of understanding. Good evidence can be quiet. Strong ideas can be graceful. The heavens can be both a clock and a poem, and an island clearing can become, for minutes at a time, an observatory large enough to hold a truth that crosses lifetimes. The plates darkened, and the stars shifted by a whisper. A theory found its reflection in glass, and a small group of patient people heard the universe say yes. Light has no weight. It cannot be held, cannot be weighed on a scale, cannot be slowed by friction or pulled like a stone through the air. Yet, it bends. It follows curves drawn by invisible hands, turning its straight path into an arc without ever feeling the strain of the turn. This simple truth unsettled the logic of a century. It forced minds to question what it means for something that has no mass to be moved by gravity, a force once thought to require weight to act. It was as if the universe itself had revealed a quiet paradox that even what is massless can be persuaded by the presence of mass, not through force, but through the geometry of existence. For generations before that realization, gravity was the ruler of matter, not of light. Newton's vision had defined the cosmos as a stage of absolute space and time, a theatre where planets spun and apples fell according to invisible tethers stretched across emptiness. In that view, the sun held Earth by an unseen rope of attraction. Space was the backdrop, flat, steady, eternal. Light, so fast and incorporeal, was a visitor unaffected by such forces. It moved straight through the cosmic theatre like a dancer ignoring the play beneath. This belief felt reasonable, comforting, and precise. But reason is not always the same as truth. Then came the equations that changed the calm stage into a living fabric. They spoke of space-time as a flexible surface, where mass did not pull, it shaped, where time itself could slow near weight, and space could tilt under its influence. A new understanding rose. Light does not bend because it is dragged. It bends because the stage beneath it is no longer flat. It is like a raindrop sliding across a curved leaf, still following the straightest path possible on that surface, yet arriving somewhere unexpected. This idea was not easy to accept. The thought that space could curve defied the habits of centuries. Philosophers had long trusted Euclid's geometry as the silent grammar of the universe. Straight lines were supposed to be universal truths. Parallel lines never met. Triangles always summed to 180 degrees. Such certainties had built architecture, navigation, and belief. To challenge them was to suggest that even geometry could be local, relative, personal to the gravity of one place. It sounded almost like heresy wrapped in mathematics. The shock grew deeper when time itself joined the distortion. If light slows near mass, not in speed, which remains sacred, but in the ticking of clocks, then simultaneity dissolves. The rhythm of one observer no longer matches another's. A second becomes a local event, not a universal beat. To think that two clocks could disagree simply because one is closer to a heavy object is to admit that the universe has moods, that it breathes differently in valleys than on peaks. For the scientific mind of the early 20th century, this was unsettling beauty, elegant and difficult to digest. Even today, the concept feels softly rebellious. To say that the sun curves space and that light follows the curve is to say that light falls not like rain, not like a stone, but like a thought obeying a hidden logic. It falls into geometry, not into gravity's hand. If one imagines light as a restless traveler crossing a great cosmic landscape, then gravity is the shape of that landscape. Where it dips, light's root dips. Where it rises, light's root rises. No force reaches out. The traveler simply moves where straightness leads, and straightness has become curved. The paradox becomes more tender when one imagines a photon leaving the edge of a massive star. It has no rest, no mass, no color, until it meets an eye. Yet, its path is already written by the curvature around its birthplace. It begins a journey that is not entirely its own. Every step of that path is dictated by a rule that needs no tug, only geometry. The photon never feels its fate. It only reveals it, millions of years later, when it arrives as a flicker of starlight in some far-off night. The same paradox applies on Earth, though it hides beneath our senses. A beam from a laser, if traced precisely enough, falls ever so slightly as it crosses a room. The drop is minute, far smaller than a grain of dust, but it exists. Gravity touches even what is massless, because the stage itself is sloped. It is not a force that acts, it is a place that bends. To understand this is to begin to see that the universe does not need tension to hold things together. Shape alone can do it. The bending of light near massive bodies is not only a curiosity, it is a declaration about the relationship between energy and space. Light carries energy, and energy itself curves space-time. The photon that bends is also a participant in the bending. The act of passing changes the stage, however slightly. Every beam of sunlight that touches Earth contributes a minuscule ripple to the geometry that guided it here. The world is not a passive recipient, it is part of the conversation. When scientists first confronted this notion, their equations felt almost too beautiful to be real. They predicted not just bending, but a deeper harmony between motion, mass, and the fabric that holds them. They found that energy, in any form, becomes gravity's partner, even light, which has no rest mass but endless motion. The more energy, the more curvature. The stronger the curvature, the more light bends. It was an interdependence that turned the old idea of force into choreography. This choreography is quiet but vast. It governs the way sunlight curves near the horizon, how galaxies appear magnified behind others, and how the universe's earliest light has reached us after billions of years through a maze of invisible deformations. The same principle that allowed a star's position to shift during an eclipse now allows astronomers to map unseen matter, to glimpse galaxies hidden behind galaxies. Light has become the tracer of space's invisible thoughts. Yet, behind the equations, the paradox remains. That which should not fall, falls. That which has no weight obeys the same law as the heaviest star. The only difference lies in how the universe whispers the instruction. It does not command with force, it persuades with form. For the listener, this becomes an oddly comforting mystery. To know that even light, the fastest, freest traveler in creation, follows the curves of the same fabric that holds every living thing, is to sense a deep unity beneath all difference. The mind that contemplates this paradox may find calm in its elegance. There is no chaos in this strange order. The bending of light does not break its nature, it completes it. The photon does not rebel against the rule. It fulfills it by moving along the truest possible path, even when that path is curved. Straightness, it turns out, can be relative. The universe, in its softness, has made room for flexibility without surrender. In that realization, tension dissolves. What once seemed contradictory becomes serene. The massless obeys, the massive, not through submission but through harmony. The universe is not a battlefield of forces but a landscape of shapes, and light is the first traveler who knows how to read it. Imagine a clock that has no hands, no gears, and no ticking sound, only two mirrors facing each other and a single pulse of light bouncing between them. Each reflection marks a moment, each journey between the mirrors a heartbeat of time. This simple thought experiment, first conceived to explore the meaning of time itself, reveals something astonishing about how the universe behaves when gravity enters the conversation. The light clock seems innocent enough, but when it is placed in motion or near something massive, the rhythm of its ticking begins to drift. Time, which we once believed to be absolute, turns out to be elastic, bending under the weight of motion and mass. In the quiet imagination of physics, such a clock helps reveal what is hidden from casual experience. When the clock moves at high speed, its beam must travel a longer path between reflections, yet the speed of light cannot change. To make sense of this, time itself must slow down for the moving clock. This is the essence of time dilation. It is not the machinery that slows, it is the unfolding of reality around it. When the same clock sits in a strong gravitational field, near a planet or a star, the same phenomenon occurs. The pulses stretch apart, seconds lengthen. Gravity, in a way, is time breathing more slowly. It is an idea that humbles and soothes at once. If time can stretch and soften near mass, then every clock in the universe keeps its own rhythm, shaped by where it stands in the gravitational landscape. The universe does not insist on uniformity. It allows individuality. A clock on the summit of a mountain ticks slightly faster than one by the sea. Satellites orbiting Earth must account for this tiny difference, so that their navigation signals stay true. To the eye, these variations are imperceptible, but to the mathematics of relativity, they are the signature of a living, responsive cosmos. This flexibility of time introduces a new way to think about light and gravity together. The photon that carries the ticking of the light clock is not just a messenger of brightness, it is the keeper of tempo. As it bounces between mirrors, it defines the local pace of existence. When gravity deepens, that pace softens. The photon takes longer to complete its journey, not because it slows, but because space and time themselves have been stretched. The distance between moments has grown. What makes this revelation so beautiful is its quiet universality. Every process that unfolds in time, every heartbeat, every orbit, every vibration of an atom is subject to the same cosmic breathing. The stronger the gravity, the slower the unfolding. Near the surface of a neutron star, time runs so slowly that what would be a second to a distant observer could feel like an eternity to one standing close. This is not illusion. It is the genuine architecture of existence, the way the universe balances energy and geometry so that no contradiction can arise. If one could descend toward a massive object with a light clock in hand, the changes would not feel dramatic at first. The clock would still tick, the beam would still bounce. Yet, viewed from far away, its rhythm would appear to drag, each reflection delayed. What is ordinary nearby becomes languid to the distant eye. Gravity does not just pull on space, it pulls on time itself, stretching intervals, dilating the experience of duration. The closer one moves to a deep gravitational well, the slower time unfolds. This interplay is not limited to imagination, it governs the precision of modern life. Atomic clocks in orbit aboard satellites must account for both motion and gravitational differences. Their corrections are tiny, but crucial. Without them, a location on Earth measured by GPS would drift by kilometers each day. What might seem like an abstract effect of relativity becomes an everyday companion, guiding journeys, mapping cities, synchronizing communications. The bending of time is woven into our technological heartbeat. And yet, beyond utility, the idea carries an emotional weight. It suggests that the universe does not unfold everywhere at the same pace. There is no single cosmic clock beating above all others. Instead, there are countless local rhythms, each a reflection of gravity's gentle influence. Time, once imagined as a single, objective flow, becomes a choir of ticking hearts, each singing at its own tempo. This realization can bring a curious calm that our perception of time's passage is not a failure of attention, but a fundamental property of where we stand in the great curvature. In deeper gravity, even light finds its tempo altered. A photon escaping from near a massive body loses some of its energy, stretching to longer wavelengths, turning redder as it climbs. This redshift is another measure of time's softness. To an observer far away, the escaping light seems to take its time, slowed not in motion but in pulse. What was once blue becomes red, not because of fatigue, but because of the stretched cadence of space and time. The universe, in this sense, is a grand instrument that changes key near mass. If one could stand near a black hole, the lesson would become visceral. As light approaches the region of no return, its clock slows infinitely to the eyes of the distant watcher. The pulses stop, frozen on the edge of darkness. For the photon itself, nothing strange occurs. It continues its motion without awareness of delay. But for the observer, time seems to halt, and the idea of before and after dissolves. The light clock at that boundary becomes a metaphor for the way gravity molds reality. It turns the steady beat of time into an asymptote, a sound that fades endlessly but never truly ends. The calm that comes from contemplating this is not the calm of certainty, but of surrender. One sees that the universe is not a rigid machine, but a breathing continuum. Gravity is not an external hand, but an aspect of time's flexibility. Light, which measures everything, also bears witness to this malleability. Each photon, each reflection, each pulse is a local truth, valid in its own rhythm. The grand unity of the cosmos arises not from uniformity, but from harmony among differences. In a sense, the light clock is more than a device. It is a reminder that the universe is alive in its geometry. Every bounce of light marks not only a distance, but an agreement between energy and space. Each stretch of time near mass reveals the patience of the cosmos, its willingness to accommodate, to adapt. To contemplate such a clock is to look into the quiet logic that binds all things, a logic that says motion and gravity are partners, and that the measure of time is never absolute, but always in conversation with the shape of the world. And so, the light clock continues its silent work, pulse by pulse, reflection by reflection. It teaches without urgency, asking only for attention. It tells a truth that comforts, that time is not lost when it stretches, only softened, that gravity does not crush the rhythm of existence, it gives it texture, and that light, ever faithful, keeps the universe's tempo, even as it learns to slow its own heartbeat near the weight of stars. The universe is not still. Every point of light that reaches an eye has wandered through an invisible architecture, a terrain carved not by stone or wind, but by gravity itself. What we see above us at night is not a flat scatter of stars, but a living tapestry of distortions. Space bends around matter, and light, obedient to geometry, follows those bends like a stream tracing the contours of a valley. This bending, when large enough, turns the cosmos into a lens so vast that it can magnify entire galaxies, duplicate their images, and stretch their forms across the sky. This idea that space could act as a lens is one of the quiet marvels of modern physics. It suggests that the very fabric of existence behaves like glass under the weight of mass. When light from a distant galaxy passes near a cluster of galaxies on its way to us, its path is deflected. The cluster's gravity reshapes space, and space guides the light accordingly. The result is a natural telescope, one not built by hands, but by the laws of geometry. The observer, unaware of the invisible curve between themselves and the source, receives multiple images of the same galaxy arcs, rings, and mirrored twins painted upon the same cosmic canvas. Astronomers call this phenomenon gravitational lensing. It can magnify objects that would otherwise be too faint or too distant to see. Sometimes, the effect is strong and dramatic. A quasar duplicated into 4 points of light surrounding a foreground galaxy, or a perfect Einstein ring forming when alignment is flawless. Sometimes, the effect is delicate and subtle, the shapes of background galaxies slightly stretched, their ellipticity revealing the presence of unseen mass. Through this quiet distortion, scientists began to measure the invisible, the dark matter that outweighs all visible stars combined. The beauty of this effect lies in its serenity. Light does not protest its bending, it adapts. It takes the path that space provides, and space has been molded by mass. Every image of lensing carries within it a whisper of both the weight of gravity and the loyalty of light. The observer, unaware, receives both the picture and the story of the journey. When telescopes collect these faint arcs, they are collecting the footprints of light that has followed the universe's most intricate roads. To imagine this clearly, one might picture a ripple of starlight traveling for billions of years. It leaves its home galaxy, crossing vast silence. Along its route lies another galaxy cluster, heavy enough to warp the surrounding space. The ripple enters that region and, instead of continuing straight, curves gently. The curve is not forced. There is no resistance, no collision. The beam merely follows the geometry, unaware that the geometry itself is not flat. Then it travels onward, arriving at Earth's instruments as though from slightly different directions. The telescope's image shows several versions of the same galaxy, each one a delayed echo of the same light, each one a different route taken through curved space. Such an event stretches not only light, but time itself. Because the paths differ, some images arrive slightly later than others. What we see is a layered memory of one distant moment unfolding across time. A supernova behind a lensing galaxy may appear once, then again, years later, as another route's light finally completes its journey. Gravity, in this sense, becomes a keeper of time's echoes, preserving moments and releasing them in slow intervals. The discovery of gravitational lensing deepened humanity's understanding of both light and gravity in a way that few phenomena could. It confirmed that space-time curvature is not an abstract idea but a tangible presence, one that shapes the very images we use to understand the cosmos. It also revealed something profound about perception itself. What we see is not always where things are. The universe we observe is a composite, filtered through the curves between us and the source. Each patch of sky is both a map and a mirage. This revelation turned gravity from a force into an artist. With infinite patience, it sculpts patterns that exist only through the cooperation of light. It paints arcs, rings, and mirrored forms with precision that no instrument could replicate. And unlike human art, which exists on the surface of things, this cosmic art lives within the geometry of existence. The lines are not drawn in pigment but in curvature, and the illumination comes from light itself. To study lensing is to read the handwriting of mass. Astronomers trace the distortions, measure the shapes, and reconstruct what must lie in the foreground to create them. In doing so, they uncover the unseen halos of dark matter surrounding galaxies, filaments stretching between clusters, webs that define the structure of the cosmos. The universe, once thought empty between its stars, is revealed as a vast network of invisible threads. Gravity is the weaver, and light is the ink. There is something restful in this realization. It tells us that nothing travels alone. Even light, swift and untouchable, is gently guided by what lies in its path. It can be delayed, redirected, divided, yet never destroyed. Its loyalty to the shape of space ensures that even in distortion, its message survives. The cosmos bends it, but does not break it. What arrives to the eye or the telescope is not chaos but choreography, an intricate alignment that speaks of balance rather than randomness. On a deeper level, gravitational lensing reveals that the universe is a place of hidden compassion. It allows light from the faintest corners to reach us, magnified by the presence of great masses. It allows glimpses of the early cosmos, that would otherwise remain unseen. Through the bending of space, gravity becomes not a barrier, but a bridge. It is as though the universe has built its own optical kindness, a system that ensures even the most distant lights are not lost in the void, but carried safely along curved paths to waiting observers. If one listens quietly to what Lensing tells, it is this: space and light are in constant conversation. One shapes the other, and through that dialogue, the story of the cosmos is written. Gravity does not merely pull, it guides. Light does not merely shine, it listens. Together they create an image of a universe that is both complex and forgiving, intricate yet tranquil in its lawfulness. Every arc captured by a telescope, every ring discovered in a deep field, is a signature of that dialogue. It says that the universe is not simply large, but subtle. It carries its truths in curves, not in edges. It reveals its depth through distortions that are, themselves, perfectly ordered. To gaze upon such an image is to see harmony in motion, structure in stillness, and to understand that even in vastness, the universe practices a kind of gentle precision. Light does not hurry. It travels with certainty, carrying the same speed everywhere, yet its journey is not always the same length. The universe, patient and deliberate, can stretch that journey without changing the traveler's pace. When light passes near a massive object, its path bends, and its clock, if light could have one, ticks more slowly. The time taken for it to cross a region of curved space-time becomes longer than expected, not because the photon hesitates, but because gravity lengthens the road it walks. This quiet phenomenon, known as the gravitational time delay, is one of the most delicate ways the universe reveals its geometry. It shows that distance and duration are not fixed, they are woven, and gravity can loosen or tighten their weave at will. The first hints of this delay appeared not in dreams but in the measured echoes of distant signals. When radio waves from faraway planets passed near the Sun on their way to Earth, scientists noticed that they arrived just a little later than predicted. The delay was tiny, a fraction of a second, but it was real. The waves had not slowed, they had simply travelled through a region of space where time was deeper, more stretched. What the instruments recorded was not a hesitation of the signal, but the patience of the cosmos itself. This effect, sometimes called the Shapiro delay, carries an elegance that feels almost poetic. It tells us that even the emptiness between objects is not truly empty. It is shaped, layered, and textured by mass and energy. When light moves through that landscape, it obeys the terrain. The straightest possible path in curved space-time can be longer than one drawn on flat space. To see a planet, a star, or a galaxy is to see not only across distance, but across bent time. Every ray of light that reaches an eye has followed a stretched path through a slow corridor. If one could travel alongside a beam of light near a heavy world, one would find that clocks in that region tick differently. What seems like a simple crossing to the traveler would, from a distant view, appear as a drawn-out moment. Light never tires, but the space through which it moves holds it longer. The photon remains true to its nature. It moves at the ultimate speed, but the measure of that motion changes because the metric of space-time itself has been sculpted by gravity. It is not a delay in the ordinary sense. It is the universe expressing patience through geometry. This patience has profound implications. When astronomers measure signals that pass near massive bodies, they must account for this elongation of time. It is not an error to correct, but a clue to cherish. By measuring the delay, one can map the gravity that caused it. In this way, time itself becomes a ruler, and the slowness of light's arrival becomes a revelation about mass, distance, and the shape of the cosmos. A fraction of a second gained or lost can trace the curve of invisible giants, planets, stars, even black holes that lie unseen, but whose gravity writes its signature in the timing of light. The calmness of this discovery lies in its subtlety. The effect is small, yet its message is vast. Space and time are not rigid, they are pliable, molded by presence. Each star, each planet, each cluster of galaxies creates a small indentation in the fabric of time. Light, like a river, moves through these valleys with grace. It never struggles, it simply takes the path that exists. The universe, through this mechanism, teaches that even in the grandest scales, gentleness is power. Nothing forces light to delay, it simply flows along a longer course because the terrain asks it to. If one listens closely to this principle, it whispers something human. The world is full of delays, pauses, moments stretched by circumstance. But in the cosmic sense, delay is not error. It is structure. It is how the universe measures its own depth. The time taken for light to reach us from the farthest galaxies, already immense, grows a little longer each time it passes a cluster or a field of dark matter. Each detour is a record of mass along its way. In the soft mathematics of the cosmos, every extra heartbeat of waiting is information. Consider a pulse sent from a spacecraft orbiting another planet. When that pulse grazes the sun on its way back to Earth, it carries the imprint of the sun's gravity in its timing. Astronomers detect the signal arriving slightly late and read from it the sun's pull, its mass, and the curvature of space around it. The sun does not speak, but the delay becomes its voice. In the faint difference between expectation and arrival lies a conversation between light and gravity that has been going on since the universe began. To imagine this delay visually, picture a valley covered in fog. A sound travels across it. To those listening on the far ridge, the echo comes slower than expected because the sound waves have wandered through thicker air and longer contours. Nothing has stopped the sound, it has simply experienced more space. Gravity creates its own version of that fog, invisible but pervasive. The light's travel time swells, and the universe becomes a resonant chamber where every beam carries not only brightness but the history of its path. In cosmic terms, these delays allow us to measure the large-scale structure of the universe itself. The way light bends and lingers tells us where the massive structures lie, how they cluster, how they evolve. It transforms patience into a method of discovery. Each late photon is a cartographer's line drawn across the unknown. The longer the delay, the stronger the gravity that caused it, and thus, the deeper the valley in the cosmic terrain. There is peace in knowing that the universe is not hurried. Even light, the swiftest traveler, participates in this serenity. It is as if the cosmos prefers thoroughness over speed, ensuring that every encounter, every gravitational brush, leaves a trace. To the eye, these delays mean nothing. To understanding, they mean everything. They are proof that reality values detail, that time's flow adapts to circumstance, that patience is built into the physics of being. When the night sky is clear, and the stars scatter their light toward us, every glimmer has been lengthened by the journey. The photons that enter our eyes are late arrivals, each one carrying the faint record of a universe that took its time. In those moments, the distinction between science and peace fades. The cosmos does not rush to reveal itself, and perhaps we should not rush to grasp it. The light that seems immediate is a collection of ancient promises kept slowly, with grace. There are places where light hesitates, not in the way that wind hesitates at the edge of a cliff, but as if the fabric of space itself holds it in quiet orbit, asking it to linger before vanishing. These are the edges of the great wells of gravity, the regions near black holes where space-time is drawn so tight that even the swiftest traveler begins to turn back upon itself. Here, photons can circle a massive object again and again, looping endlessly on invisible tracks known as photon spheres. Light, usually the emblem of motion, becomes captive to geometry, neither free nor lost, just caught in eternal hesitation. A photon sphere is not a surface you could touch. It is a radius, a distance where gravity bends the rules just enough to make light chase its own path. For a black hole, this radius lies at 1.5 times the distance of its event horizon. Any light that happens to pass at exactly that distance will orbit forever, trapped in a closed loop, seeing the universe only as a smear of directions repeating infinitely. Move slightly closer, and the photon spirals inward, consumed by the horizon. Move slightly farther, and it escapes, bent but free. Between those fates lies a delicate equilibrium, a knife's edge, where light becomes a monument to indecision. The existence of such spheres reveals the intimacy between gravity and light at their most extreme. Far from massive bodies, light treats gravity as a gentle guide, curving only slightly. Near black holes, the conversation deepens into intensity. Gravity no longer whispers, it shapes light's destiny outright. To an observer, the photons looping near the photon sphere form a glowing ring around darkness, not because the black hole emits light, but because it delays and redirects light from the world behind it. This ring is a visible echo of hesitation, an image made from photons that almost fell but changed their minds at the last instant. At the boundary beyond, the event horizon, hesitation becomes final. Nothing that crosses it can return, not even light. To the outside world, a beam approaching that horizon appears to slow endlessly, fading into red as it tries to escape. Time itself, near that edge, is stretched so long that the last flash seems to freeze. For the photon, there is no pause. It continues to move forward at full speed, unaware that the geometry beneath it has become a funnel with no exit. The observer, distant and patient, sees the light vanish asymptotically, as though swallowed not by force but by stillness. These regions defy ordinary intuition. Gravity here does not merely bend paths, it redefines what a path can be. The shapes drawn by light around black holes are not straight lines or curves in the familiar sense. They are geodesics on a surface of time and space that has folded upon itself. To describe them is to admit that direction and duration lose their usual meanings. A photon circling a black hole does not move through space as much as it moves through the definition of space itself. Astronomers, using instruments that collect the faintest signals, have learned to trace these effects indirectly. When material falls toward a black hole and heats to incandescence, its emitted light must pass through the warped space near the photon sphere. The resulting pattern of light, smeared and delayed, forms what we call the black hole's shadow, a dark circle surrounded by a glowing ring. That glow is not the black hole shining. It is the universe reflected through light that has danced on the edge of disappearance. It is the patience of photons given visible form. To imagine what it would be like near such a region is to abandon the comfort of normal perspective. The sky would curve inward. Stars would appear in impossible arrangements, their light bent around the hole in all directions. Behind, ahead, and above would blur into one continuous field. A person watching another approach the horizon would never see them cross it, only fade, stretched into eternity. The notion of a fixed up or down dissolves. What remains is geometry performing its most intricate movement, quiet and absolute. This behavior also reshapes time itself. Near a black hole, clocks slow to almost stillness when measured from afar. What might feel like a brief descent to the traveler becomes an eternity to the observer watching from safety. This dissonance of perception is not an illusion, it is the structure of space-time expressing its curvature. Gravity here is not merely a pull but a sculptor of time, deciding how quickly moments can pass. Light, caught in its field, marks that sculpture with orbits that trace the limit between motion and rest. Even in these extremes, there is order. The photon sphere, though fragile, is stable in its own way. It defines the threshold between those paths that fall and those that escape. It is a geometric boundary written into the equations of relativity, a boundary that mirrors the delicate balance found everywhere in nature between flow and stillness, between freedom and belonging. Light, by circling that edge, becomes both witness and participant in gravity's artistry. To the contemplative mind, this dance holds a strange comfort. It shows that even in places of unimaginable intensity, the universe keeps its harmony. Light does not vanish without trace. It folds into new patterns. Gravity does not destroy form, it transforms it. The photon sphere is a meditation in motion, a reminder that hesitation can be eternal without being futile. The notion of light orbiting nothing but a hole in space-time might feel eerie, but it is also profoundly peaceful. The black hole, for all its appetite, maintains balance with precision. Every photon it swallows is another thread woven into the fabric of cosmic structure. Every photon it deflects adds a stroke to the grand image we see from afar. The event horizon may seem like an end, but it is also a transition, a threshold where the definitions of inside and outside lose meaning. The light that circles it becomes a memorial to motion, a record of geometry's patience. When images of black holes were first captured, showing a dim heart surrounded by a luminous ring, humanity saw the physical manifestation of this hesitation. It was not chaos or violence, but symmetry, the cosmos caught in a moment of perfect balance between the infinite and the finite. That image, more than a scientific achievement, was a portrait of gravity's gentleness under pressure, of light's loyalty to geometry even when faced with nothingness. To look upon that ring, even in imagination, is to feel the calm at the edge of the absolute. Here, motion and stillness become the same. Time folds inward, and light performs its final orbit, neither falling nor fleeing but existing in a perpetual curve. The photon sphere is the universe whispering that nothing is truly lost, only transformed, slowed, curved, and held in an endless embrace between brightness and shadow. In the deep stillness of space, there are tremors that cannot be seen but can be felt by the fabric of reality itself. They are not waves of air or water, but of space-time, the medium that carries every star, planet, and atom. When colossal objects like black holes or neutron stars collide, they send ripples through the universe, stretching and squeezing everything in their path. These are gravitational waves, the faint echoes of cataclysm written in the language of geometry. And though they pass through galaxies, through light, through matter, they do so silently, leaving behind a trace of their rhythm in the ways light moves afterward. These waves are unlike anything else. They carry no color, no warmth, no visible form, yet they are real enough to alter the distance between mirrors, to whisper in the machinery of precision, and to shift the beat of clocks. They were predicted long before they were ever detected, hidden inside the equations that tie gravity to the shape of the universe. Their arrival in our instruments confirmed what had long been imagined, that the universe does not merely exist in silence, it sings, and every collision is a note in its endless score. Light, though separate from these waves, feels their passing. When a gravitational wave moves through a region of space, the distances between points expand and contract. The light that crosses that region must adjust, its wavelength stretching and compressing with the tide. In this way, light and gravity perform a duet. One carries brightness, the other carries motion, and together they form a cosmic harmony of rhythm and radiance. The detection of these waves required a sensitivity beyond anything humanity had built before. Giant interferometers, miles long, were designed to measure changes smaller than the width of an atom. Each one sent laser beams down 2 long tunnels at right angles. If a gravitational wave passed through, it would alter the lengths of those tunnels by an infinitesimal amount, one arm stretching, the other contracting. The returning light waves, recombined, would then interfere in a pattern that revealed the ripple's passage. When, at last, the first signal arrived, a soft, rapid oscillation lasting less than a second, it was the universe itself speaking through geometry. 2 black holes had merged over 1 billion years ago, their spiraling dance releasing more energy in gravitational waves than all the stars in all galaxies combined emit in light at that moment. Yet here, on a small planet orbiting an ordinary star, that colossal event arrived as a tiny shift in a beam of light. The instruments registered it, and for the first time, humanity listened to the universe not by sight, but by feel. That moment changed how we sense reality. Before, we saw the cosmos as a painting silent, distant, and vast. Afterward, it became a symphony. Every massive collision, every orbiting pair, every neutron star tearing itself apart now had a voice, and through those voices, light gained new meaning. Light became the narrator of gravity's music. When gravitational waves pass, light follows their rhythm, bending and stretching in sympathy. Consider how delicate that interplay is. The waves that reached Earth had traveled across billions of light years, yet when they arrived, they moved the mirrors of the detectors by less than 1/10,000th of a proton's diameter. The precision required to notice such a shift is almost beyond comprehension, but that precision speaks to the profound calm of the universe, a calm that exists not because nothing happens, but because even the most violent events unfold in balance. The gravitational waves that sweep across creation are gentle enough to pass through galaxies without leaving scars. This harmony between light and gravity reveals something fundamental about existence. The two are not separate kingdoms but expressions of the same geometry. Light travels through the space-time that gravity shapes, and when that space-time ripples, light dances with it. Every photon that reaches a telescope, every beam from a distant quasar, has likely crossed countless waves of distortion, each one stretching its wavelength by the smallest fraction. The light carries these imprints as if bearing the fingerprints of cosmic events we can barely imagine. Sometimes, light and gravity conspire to make their duet visible. When 2 neutron stars collide, The crash produces both gravitational waves and a burst of electromagnetic light, gamma rays, X-rays, radio waves. Observatories tuned to different parts of the spectrum catch the light, while detectors like LIGO and Virgo catch the ripples. When both are seen together, a new kind of astronomy emerges, one that listens and watches at once. Through these twin signals, scientists can measure distances more precisely, study the expansion of the universe, and test whether light and gravity truly move in lockstep. So far, they do, as though keeping time in a shared rhythm older than stars. There is comfort in this unity. It means that even across unimaginable distances, the laws of nature remain faithful. A wave of gravity launched by a dying star and a photon of light released by the same explosion will cross the cosmos together, separated by nothing but their mode of expression. One stretches space, the other illuminates it. Both arrive to tell the same story, that the universe, for all its vastness, is coherent, its language is geometry, and all its movements are fluent in that single, elegant tongue. If one could stand somewhere in the dark void between galaxies and listen with infinite sensitivity, the universe would not seem empty. It would hum softly, endlessly, with the low notes of merging black holes, the midtones of orbiting binaries, the high tremors of neutron stars spinning apart. Light, in that place, would flicker gently, its path subtly distorted by each passing wave. Together they would create a cosmic lullaby, a song of slow motion and deep order, neither chaotic nor still, but infinitely patient. To reflect on this is to feel small but comforted. The same waves that pass through distant constellations pass through us, stretching our atoms imperceptibly, brushing through our lives unnoticed. Yet, they remind us that we belong to the same fabric that carries light from star to star. Every ripple, every photon, is part of one ongoing conversation, the universe speaking to itself across eternity. Light and gravitational waves do not compete. They complement, completing each other's story. Light shows us where events happen, gravity tells us how deeply they matter. And through their combined presence, we learn that the cosmos does not only expand outward, it resonates. Its silence is full of motion, its darkness full of music, and its stillness full of meaning. In the cold and quiet aftermath of the universe's birth, light began its longest journey. It was not the bright, visible light we know, but a pale glow stretched across time, the cosmic microwave background, the first whisper of photons freed to roam. This ancient radiation, older than galaxies, is the fossil light of creation. It carries within its gentle uniformity the record of gravity's first act, when the universe itself was a thick soup of matter and energy struggling toward transparency. Before that moment, the cosmos was opaque. Particles of light could not travel far without colliding with electrons and protons. The universe was dense and hot, more like a fog of fire than a starry expanse. But as it expanded, it cooled. The day came when temperature and density dropped enough for electrons and protons to unite into neutral atoms. With that, light was released. Photons, once imprisoned in the glowing fog, broke free and began their voyage through space and time. They have been traveling ever since, spreading outward as the universe stretches, their wavelengths lengthening into the microwave range. Those photons carry a perfect calm, a nearly uniform temperature, only a few degrees above absolute zero. Yet hidden in that calm are the faint fingerprints of gravity's first sculpting. Tiny fluctuations, no larger than 1 part in 100,000, mark where gravity had already begun to gather matter. These subtle differences in temperature are the earliest signs of structure, the first seeds from which galaxies, stars, and planets would one day grow. The light we detect from that era is both a relic and a prophecy. It shows how gravity began shaping the cosmos long before any eyes existed to witness it. To look at the cosmic microwave background is to look at the memory of the universe itself. It is not an image captured by a telescope in the usual sense. It is a map of time, a record of when gravity first gave order to chaos. When satellites like COBE, WMAP, and Planck charted its faint irregularities, they revealed not randomness but rhythm. The pattern of those ripples matched the delicate balance between light and gravity during the universe's infancy. Light pushed outward, gravity pulled inward. Between them arose oscillations, waves of compression and rarefaction that rippled through the primordial plasma. These were the first harmonies of existence, the first physical music the cosmos ever played. Those oscillations are still visible today, frozen into the background radiation that fills all directions. Every point of the sky glows with nearly the same brightness, yet the tiny variations tell a profound story. They reveal how the universe has expanded, how much matter it holds, how fast that expansion continues. They also reveal the fingerprints of the invisible dark matter and dark energy whose presence shaped the balance between light's pressure and gravity's embrace. From that balance emerged everything: stars burning, galaxies spinning, and the long chain of structure that led, eventually, to us. The calm perfection of this background might seem uneventful, but in truth it represents the most informative silence imaginable. Each photon in that ancient light has traveled for nearly 14 billion years without losing the imprint of its birthplace. They come from every direction equally, as if space itself remembers the first breath it took. When we receive them through sensitive antennas and detectors, we are listening to the oldest light in existence, a soft murmur of equilibrium still echoing from the universe's earliest dawn. What makes this light so relaxing to contemplate is not just its antiquity, but its gentleness. It is the most even thing we know. No violent flashes, no sudden breaks, only a smooth wash of energy, nearly identical wherever one looks. And yet, that near perfection hides the faint asymmetries that made everything possible. The universe, it seems, needed a touch of imbalance to become interesting. Gravity took those minute differences and amplified them, drawing matter together over billions of years into stars and galaxies. The cosmic microwave background is, therefore, not a still image, but a slow unfolding, a quiet record of becoming. Even more remarkable, the polarization of this ancient light encodes the traces of the universe's earliest movements. Swirling patterns in that polarization point to the influence of gravitational waves from the first instant of creation, waves that rippled through space-time itself during the inflationary epoch, when the universe expanded faster than light could cross it. These fossil waves, if confirmed with full certainty, would be the first direct evidence of gravity's participation in the universe's birth. In that way, the cosmic microwave background becomes not just a map of light, but a diary of gravity's first conversation with the cosmos. From a human perspective, this light is humbling in its patience. It has crossed uncountable distances without fading, altered only by the slow stretching of space. Each microwave photon has passed through clouds of dust, through clusters of galaxies, through gravitational wells that have subtly shifted its frequency. Yet, after billions of years, it still carries the memory of its origin. It reminds us that information, once set free by light, endures. The universe remembers, not in words, but in temperature and pattern. If one could stand outside all of time and look at the unfolding of the cosmos as a single breath, the cosmic microwave background would appear as the moment that breath first left the lungs of creation. It is the soft exhale after the explosive inhale of the Big Bang, the point where expansion became expression and gravity began its lifelong role as the sculptor of form. The light that once filled every corner of existence now whispers from beyond, stretched thin but never silent. To gaze upon this ancient radiation is to experience peace in its purest form. It asks for no interpretation, no belief. It simply is the steady residue of a universe that found balance early and has been refining it ever since. Every photon within it is a survivor of the first dawn, every ripple a signature of gravity's first gesture. Together they form the quietest possible proof that light and gravity have always been companions, even at the beginning. In its faint glow, we find both origin and destiny. The same forces that sculpted the early plasma continue to shape the galaxies we see now. The same conversation between radiance and curvature continues, slower but unbroken. The cosmic microwave background is not just a relic, it is the lullaby the universe still hums to itself, the background music of being. It is what remains after the first chaos settled into law, after light was freed, and after gravity found its rhythm. And in that rhythm, the cosmos learned to rest. When light climbs out of gravity's grasp, it changes its voice. Its tone stretches, its color deepens, Its wavelength grows longer, like a musical note sliding down the scale. This quiet transformation is called gravitational redshift, the softest evidence that even light, though weightless, feels the patience of gravity. It does not lose speed, but it leaves behind a fraction of its energy as it rises. What was once a bright blue gleam near a massive body becomes a mellow red farther away. Time itself seems to stretch between those wavelengths, and the universe in that moment speaks in a slower rhythm. This effect, though subtle, carries deep meaning. It shows that light's frequency is tied to the very pace of time. Where gravity is strong, clocks tick slower, and so the oscillation of light's wave, its color, follows suit. To stand on the surface of a dense star and shine a beam upward is to watch it age as it travels. By the time it reaches a distant observer, its energy has softened, its heartbeat slowed. Nothing has interfered with it, nothing has absorbed it. The universe has simply allowed it to stretch through the curved geometry that defines how time flows. In that stretch lies a truth both scientific and poetic. Light, like all things, participates in the dialogue between energy and space. It cannot escape the conversation. The same law that governs the fall of an apple governs the slow, graceful slide of a photon's frequency as it ascends. Each wave of light, in this sense, is a climbing traveler that leaves behind a little of itself to reach the summit. Astronomers first measured this effect in laboratories by comparing the frequency of light emitted from the top and bottom of tall towers. The difference was infinitesimal, yet measurable. Later, they found the same principle written across the sky, in the red-shifted light of stars near massive bodies, and in the soft background glow that fills the cosmos. Every instance confirmed that time runs differently under different weights, and that light, as it crosses those boundaries, carries the record of that difference. The gravitational redshift is not to be confused with the redshift caused by motion or expansion. It is not the universe's stretching that causes it, nor the retreat of galaxies from one another. It is the deepening of time itself around mass. Where gravity curves space-time, light's waves are drawn longer, not because they slow, but because their cycles stretch with the very fabric they move through. This subtle act of dilation gives the universe its layered texture, a depth in which color becomes a measure of time's contour. Consider the light leaving the surface of a neutron star. The gravity there is so intense that time runs 30% slower than on Earth. A photon emitted as violet near that surface may arrive to a distant observer as red, its oscillations spread out by the warping of space-time. The star itself does not dim, its light is simply aged by the climb. What was a high, quick song at the surface becomes a slow, low hum in the open sky. The redshift is, therefore, not a loss, but a translation, the same melody played in a lower key. This translation reveals a quiet beauty in the universe's design. Energy and time are intertwined, and gravity mediates their relationship. When light loses frequency, it gains distance. When it slows its rhythm, it records the shape of the world it left behind. The act of redshifting becomes a kind of memory, a way for the cosmos to preserve the evidence of its own curvature. Every beam of starlight that reaches an eye has been tuned by this invisible hand, each one carrying a small echo of the gravitational landscape it crossed. This phenomenon also connects to the very edge of understanding the horizon of black holes. As light tries to escape from that boundary, its wavelength stretches toward infinity. To an outside observer, the photon never emerges. Its redshift grows without limit, its color fading into invisibility. The black hole becomes black not because light cannot be emitted, but because the redshift near its horizon is absolute. Time there is so slow that light's oscillation appears to stop. What once flickered becomes eternal stillness. Yet even this extreme version of redshift holds a strange peace. It shows that the laws of nature remain consistent even where time nearly halts. The photon obeys the same rule at the edge of a black hole as it does above the surface of the Earth. The stretching is continuous, gradual, inevitable, and precise. The cosmos may vary in scale, but not in loyalty. Every star, every world, every atom experiences the same graceful transition, adjusted only by the depth of its gravity. There is an emotional gentleness in this law. It tells us that light does not break under pressure, it adapts. It gives a little of its color to the gravity that holds it, much like a traveler leaving an offering before continuing on the road. What it loses in frequency, it gains in meaning. The redder the light, the longer the climb, the deeper the memory of its journey. When we look at redshifted starlight, we are seeing not just distance, but experience. Each photon that arrives carries a story of escape, of ascent through time's gradient. Even the universe itself performs this transformation on a cosmic scale. As it expands, the fabric of space stretches, and with it, the light from ancient galaxies. Though this cosmological redshift differs in cause, it resonates with the same theme, light adapting to the shape of reality. Every photon becomes a chronicle of its own voyage, stretched by both gravity and expansion. The cosmos paints its age in crimson tones. To contemplate gravitational redshift is to find calm in inevitability. It is not a violent process. There is no tearing, no breaking, only a soft lengthening. The universe does not rush to reveal color. It lets light fade gently, like music dissolving into echo. Each step up a gravitational well, each ascent from mass to openness, is accompanied by this slowing of the photon's song, and in that slowing lies an invitation to reflect. If the universe allows even light to rest on its way, to change pace without losing purpose, then perhaps rest itself is not the opposite of motion, but its refinement. Gravity's hold and light's resilience, seen together in the redshift, remind us that strength can be measured not in resistance but in grace. The deeper the well, the slower the climb, and yet the light still rises. Always it rises. There is a photograph that changed how humanity imagined the unseen. It shows a ring of light surrounding a darkness so complete that it appears to devour even the idea of color. This is the image of a black hole, captured not through a single lens but through a network of telescopes scattered across Earth, all synchronized to gaze at the same patch of sky. The ring glows softly, a golden halo shaped by gravity itself. It is light drawn to the edge of no return, sculpted into a circle by the pull of space-time. What we see in that image is not the black hole directly, but the story of how light behaves when faced with the end of motion. The Ring of Fire is more than a spectacle. It is the visible boundary between the possible and the impossible. Each photon in that ring once came from gas and dust swirling around the black hole at nearly the speed of light. These particles collided, heated, and released radiation that tried to escape. Most of that radiation fell back into the abyss, swallowed before it could flee. But a fraction skimmed along the edge, following paths that curved and folded through warped space-time before finally reaching us. The result is a luminous outline, the last testimony of light before silence. In this glow, gravity reveals its elegance. It bends light, not violently but precisely, arranging the escaping rays into a structure that obeys perfect geometry. The brightness of the ring is not uniform. One side shines stronger because light moving toward us is compressed in frequency by motion, while the other side, moving away, is dimmed. Even here, relativity writes symmetry in asymmetry. The black hole's spin twists the fabric of space, pulling nearby light into a spiral. Yet the overall form remains serene. It is chaos disciplined by mathematics, wildness contained within order. When the Event Horizon Telescope assembled its mosaic of data in 2019, it produced more than an image, it produced a mirror for the human mind. For centuries, black holes were abstract solutions, theoretical points where equations broke down. To finally see their shadow made them real. Yet, what appeared was not a monster or a maw, but something almost tranquil. The dark center is not a hole in space, it is space itself turned inward, a region where time and geometry have changed roles. Inside that horizon, the direction of time points inward, not forward. The ring that surrounds it is the final surface from which light can still escape, a luminous memorial to all that crosses beyond. If one could stand near such a place, the experience would be unlike anything else. The sky would no longer resemble the familiar dome of stars. Instead, light from every direction would bend and converge, forming a distorted panorama of the universe above and behind. Every photon that reached the eye would have traveled through a twisted landscape of time. The horizon would not appear as a wall, but as a sphere of stillness, perfectly black, perfectly calm. Around it, the accretion disk would blaze with energy, its brightness intensified by speed and gravity alike. It would be a spectacle not of destruction, but of precision energy surrendering to geometry. The Ring of Fire also carries within it a delay, a kind of temporal echo. The photons that make up its light have taken longer paths than those traveling directly through space. They have looped near the photon sphere, some circling the black hole once, others multiple times, before escaping. What we see in a single moment is therefore a composite of events stretched across time. The ring is not an instant frozen, but a harmony of durations, light from many orbits arriving together. Each orbit tells a slightly different story, yet all blend into one calm glow. There is also mystery in its thickness. The width of the ring encodes the scale of the black hole's mass and the strength of its spin. For the black hole in the galaxy M87, the one we first imaged, that ring represents the shadow cast by a monster 6 billion times the mass of our Sunday. Its diameter would encompass our entire solar system, yet from Earth, it appeared as small as a grain of sand, seen from miles away. To make such a thing visible required coordination across continents, synchronizing telescopes with atomic clocks to create an Earth-sized eye. The effort mirrored the very phenomenon it sought to observe, a global unity bent toward a single focus. What the image offered was not just proof of theory, but reassurance of consistency. The brightness, the diameter, the structure all matched the predictions of general relativity within remarkable accuracy. The universe, once again, had behaved exactly as the equations whispered it would. This confirmation carried an almost spiritual quietness. To see order emerging from such intensity, to witness geometry holding its line even at the brink of nothingness, was to feel that the cosmos is faithful to itself. The black hole's ring, sometimes called the photon ring, will continue to evolve. As instruments grow sharper, scientists expect to see finer details, multiple concentric rings formed by light that has orbited several times before escaping. Each ring will be fainter and smaller than the last, like ripples around a stone cast into space-time. Together, they will form an infinite series of echoes, each a record of light's resilience, each a gesture of gravity's artistry. There is comfort in this repetition. It means that even where time nearly halts, the universe still finds rhythm. The same laws that guide falling apples and orbiting moons guide the spirals of light around black holes. No special exception, no rupture of logic, only continuity carried to its ultimate limit. What was once feared as the end of understanding becomes instead its perfection, a smooth convergence of curvature, energy, and time. When one looks upon that ring, one does not see destruction, one sees balance. The darkness at its center is not chaos, but completion. The light around it is not agony, but surrender. Together they form a portrait of gravity at peace with light, of energy finding its final shape in the geometry that created it. And so, the Ring of Fire becomes a symbol not of fear, but of stillness. It shows that even at the edge of eternity, order prevails and beauty persists. Light, though destined to fade, leaves its mark in perfect circles. Gravity, though fierce, sculpts those circles with grace. In that eternal embrace, the glowing ring and the silent core, the universe reveals its gentlest truth, that every ending can also be a form of illumination. In the heart of the void, where even light cannot escape, gravity does something unexpected. It glows, not in brightness that can be seen with eyes, but in a faint radiance born of theory and quantum law. This is Hawking radiation, the gentle warmth of emptiness, the suggestion that even nothing is not truly nothing. Where gravity presses hardest and space-time folds into silence, quantum mechanics finds a whisper of light. It is as if the universe refuses to let darkness have the final word. To imagine how this happens, one must think small, smaller than atoms, smaller than the smallest particle we can name. Quantum theory tells us that empty space is restless. It seethes with brief appearances and vanishings of pairs of particles, one positive, one negative, flickering into existence for the briefest instant before annihilating each other. Normally, these pairs leave no trace. They are the quantum heartbeat of the vacuum, constant and self-cancelling. But near the edge of a black hole, where gravity distorts time itself, the two particles can become separated. One falls inward, while the other escapes. The escaping particle carries away energy. To distant eyes, That energy appears as radiation, a soft, steady emission from a place that should emit nothing. To preserve the balance, the black hole loses a tiny fraction of its mass. Over immense stretches of time, this slow leak means that even the most silent object in the universe can evaporate. Gravity, which once only consumed, can also give back. The concept is startling but serene. It bridges two worlds that once seemed opposed, the smooth curvature of general relativity and the jittering uncertainty of quantum mechanics. In Hawking's insight, these opposites found a conversation. Gravity, which shapes space-time on the largest scales, and quantum physics, which rules the smallest, meet at the horizon of a black hole. The result is not conflict, but a quiet compromise. The void becomes creative. If one could stand near that horizon, though no body could survive the journey, one would find the scene paradoxically calm. There would be no roar, no glow, no visible flame. The radiation is faint beyond imagination, its temperature inversely proportional to the black hole's mass. A stellar black hole glows colder than the cosmic background that surrounds it, invisible against that greater warmth. Only when the black hole shrinks to a microscopic size, after countless eons, would its temperature rise enough to become noticeable. Then, at the end of its life, it would flare briefly and vanish in a final pulse of light. This slow unraveling turns the black hole from a symbol of permanence into a participant in time. It shows that even the most absolute structures in the cosmos are impermanent, that gravity's grasp loosens eventually, not through force but through the persistence of quantum uncertainty. In the infinite patience of physics, nothing remains unchanged. Every field, every particle, every shadow obeys the rhythm of transformation. There is deep comfort in this realization. The black hole, once thought to be an eternal grave of matter and light, becomes instead a process, a cycle of absorption and release. Energy that fell inward returns to the universe in subtle form. The same space-time that sealed off light now breathes it out again, slowly, gently, invisibly. It is as though the cosmos, even at its darkest, practices forgiveness. Yet, Hawking's idea also leaves behind an unresolved question, one that stirs physicists and philosophers alike. If a black hole can evaporate, what happens to the information that once fell into it? Does the universe lose memory? Or does it preserve it somehow within the fabric of the radiation? Quantum theory insists that information cannot be destroyed. Relativity seems to say otherwise. Between those two principles lies the information paradox, one of the deepest puzzles in modern thought. Some theories suggest that information is encoded subtly in the radiation itself, that each escaping particle carries a faint trace of what once crossed the horizon. Others imagine that space and time must be rewritten altogether at quantum scales, so that the idea of inside and outside dissolves. Whatever the answer, the discussion itself reveals something timeless, that the universe, for all its mystery, invites interpretation rather than despair. Each new paradox is not an obstacle, but an opening. From a broader perspective, Hawking's radiation can be seen as the thermostat of the cosmos, a balancing act that ensures no corner of existence is entirely cut off from the flow of energy. Black holes, those symbols of absorption, become regulators of equilibrium. They take in, they emit, and they vanish in proportion to the laws that govern everything else. Even the darkest points of the universe obey the same conservation as stars and atoms. There is justice in that symmetry. In more poetic terms, one might say that the black hole dreams. Its darkness is not final sleep but long meditation, ending with a sigh of light. The evaporation may take longer than the lifetime of galaxies, but the principle holds: what begins as collapse ends as release. Gravity's most extreme act, the swallowing of light, becomes, through quantum patience, an act of creation. Out of the pressure of space-time itself, photons are born anew. This quiet exchange between gravity and quantum mechanics redefines what emptiness means. The vacuum is not the absence of being, it is the raw potential for it. It is a stage that hums beneath perception, where particles dance in and out of existence, and where gravity, subtle and precise, turns even silence into a source of light. The very emptiness between stars becomes alive with invisible warmth, an echo of all that has ever fallen into darkness. For the reflective mind, this discovery offers solace. It means that no loss is absolute, no disappearance final. Energy returns in forms we cannot easily perceive, but which remain consistent with the laws that bind everything. The cosmos, vast and unfeeling though it may seem, practices continuity. Every fall is balanced by a rise, every collapse by an emission. In the faint glow of Hawking's idea, we glimpse an unexpected tenderness, gravity and light. Once seen as opposites, one pulling inward, the other rushing outward, meet again in the black hole's sigh. The two forces that define existence reconcile at the edge of nothingness, proving that even in the darkest equations, the universe leaves room for mercy, for rhythm, and for return. Night on Earth carries an ancient rhythm, a pulse of observation that connects the human gaze to the quiet machinery of the cosmos. Across deserts, mountains, and frozen plains, instruments wait beneath domes that open like the petals of metal flowers. Inside them, telescopes align their mirrors with exquisite precision, following the faint tremors of light that have crossed billions of years. Each photon that falls upon those detectors is a messenger, and every message is shaped by gravity. The tools that catch these whispers have become extensions of human patience ears, tuned to the silence of the night. Among these instruments are the great observatories of our time, built to see not only what glows, but how that glow bends, delays, and stretches under gravity's influence. Some of them trace the bending of starlight near massive galaxies, measuring the invisible architecture of dark matter. Others listen for the time delay of signals as they pass near planets or the sun. Together, they form a vast symphony of perception, turning the subtle effects of relativity into sound, image, and data. Modern telescopes, both on Earth and in orbit, do more than collect light, they translate geometry into music. When a beam arrives slightly redder, slightly late, or slightly bent, computers interpret those deviations as messages about curvature. In this way, the universe teaches through nuance, and technology learns to listen with increasing sensitivity. The precision is astonishing. Atomic clocks aboard satellites keep time so accurate that their drift is measured in billionths of a second. Interferometers can detect shifts in length smaller than the width of a proton. Each refinement brings gravity and light into sharper focus, revealing their shared grammar. One can imagine the observatories at night, vast mirrors turning silently, red lights glowing faintly inside control rooms. Astronomers sit before monitors showing specks of light that represent entire galaxies. A signal flashes briefly on a graph. Somewhere, a pulse from a distant pulsar has arrived, slightly delayed because its radio waves passed near a massive object. That tiny delay, measured in microseconds, confirms that space-time is curved exactly as theory predicts. In such moments, knowledge feels like reverence. The universe does not shout its truths, it whispers them in precision and patience. Gravitational wave observatories extend this listening to another realm. Their arms stretch for kilometers, and within them, laser beams cross paths in perpetual silence. When a ripple of space-time passes through, the pattern of interference shifts just enough to mark the event. The detectors are so sensitive that they must be shielded from footsteps, traffic, even the tremor of ocean waves. They operate at the edge of perception, where noise and signal are almost indistinguishable. Yet, through their stillness, they hear the universe breathe. Radio telescopes, meanwhile, listen to the cosmos in longer wavelengths, the sighs of pulsars, the faint echoes of distant galaxies, the background hum left from the beginning of time. Each one maps not only brightness but delay, using the distortions caused by gravity to measure distance, mass, and motion. When two or more of these telescopes are linked across continents in a technique called very long baseline interferometry, they function as one immense eye the size of the planet itself. With it, humanity can see rings of fire around black holes, trace plasma jets escaping from galactic cores, and measure how light itself hesitates near massive bodies. There are also clocks that live in orbit satellites moving through the delicate gradient of Earth's gravity. They must correct their timing constantly because time runs differently above and below. Without those adjustments, navigation systems would fail, and our world's synchrony would dissolve by kilometers each day. In their constant calibration, these satellites prove daily that Einstein's description of time and gravity was not just theory, but the operating manual of the modern age. Even our most practical technologies are, in essence, quiet proofs of relativity. The beauty of these tools lies not only in their complexity, but in their humility. They are built not to command the cosmos, but to listen to it. Every mirror, every sensor, every antenna is a gesture of attention. Each reflects a belief that truth is patient, that understanding comes not through dominance but through stillness. Science, at its most elegant, becomes a form of meditation, a long exposure of the mind to the night. There is also artistry in their design. The great radio dishes curve like frozen waves. The segmented mirrors of optical telescopes gleam like petals of glass. Deep underground, where gravitational detectors are shielded from the noise of the world, corridors hum with quiet machinery that measures the stretching of space-time itself. Each of these places is a temple to light and gravity to the way they shape and reveal one another. Sometimes, these instruments catch coincidences so precise that they feel choreographed. A burst of gamma rays detected by one satellite is matched to a gravitational wave recorded by another observatory moments earlier. The data converges, confirming that two neutron stars have collided in a distant galaxy. From the merger come both light and gravity, arriving in harmony after traveling for billions of years. The instruments record the moment together, and through them, humanity witnesses the universe perform its most ancient duet. Even the imperfections of these tools tell a story. Noise in their data reminds us that our planet is alive, vibrating, breathing, shifting. The hum of the ocean, the heartbeat of tectonic plates, the passing of wind across antennas all mingle with signals from the cosmos. It is as if the Earth itself participates in the act of listening, lending its subtle motion to the music of space. At the edge of it all stand the scientists who interpret these whispers. They work in quiet rooms filled with graphs and code, but their attention stretches to unimaginable distances. When they speak of redshift, lensing, or gravitational waves, they are translating light's language into human understanding. They are, in essence, poets of precision, their verses written in data, their rhymes in calibration. Through their instruments, we have learned that the universe is not distant but continuous, that light and gravity are threads in the same fabric. Every measurement, every detection confirms that space is alive with interaction. Light does not travel through nothingness, it moves through a field that bends, breathes, and responds. And by listening closely enough, humanity has learned to hear the heartbeat of that field. Perhaps this is why these instruments feel almost spiritual. They remind us that to know the cosmos is not to conquer it, but to join its rhythm. The telescopes and detectors do not force revelation, they wait. They prove that silence can be generous, that patience can yield vision, and that even the faintest signal, if listened to long enough, can carry the voice of gravity itself. Each generation of science inherits the same quiet question: how can we test the universe's most delicate promises? Gravity bends, light obeys, time slows, and space curves. Yet the proof of these truths must be gathered one measurement at a time, like raindrops in a vast invisible storm. In observatories, in spacecraft, in orbiting clocks, and deep beneath mountains, the testing continues. Every experiment is an act of patience, a repetition of curiosity that asks, again and again, whether the cosmos remains faithful to its geometry. In the thin air above mountain peaks, telescopes still capture the faint distortions of light from distant galaxies. Astronomers measure how their shapes twist subtly, not by random chance, but by gravity's invisible fingerprints. This effect, called weak lensing, lets us map dark matter, the unseen scaffolding that holds the visible universe together. From these maps, a pattern emerges. Gravity behaves as expected, yet its source is far greater than what stars alone can provide. The universe seems filled with something unseen, shaping light's path with a hand we cannot touch. Each photograph of 1,000 galaxies becomes a chart of invisible curves, a testimony to an unseen weight that keeps the cosmic web intact. Above the clouds, satellites trace their orbits with relentless precision. Their onboard clocks tick in harmony with relativity's laws. A signal sent from one to another arrives slightly off if Einstein's corrections are removed, a delay so small, yet so consistent, that entire technologies depend on it. The Global Positioning System, guiding ships and aircraft and phones, is a living experiment in gravity and time. It proves, moment by moment, that the pace of time depends on altitude, motion, and mass. Without acknowledging that truth, civilization would lose its bearings. The accuracy of a map, the landing of a plane, the synchronization of a financial network, all are silent tributes to the bending of space-time. In the void between planets, probes send radio pulses back to Earth. As those signals pass near the Sun, their travel time lengthens slightly, a direct echo of the gravitational delay first imagined decades ago. By comparing the delay against predictions, scientists verify once more that gravity bends not only light, but time itself. The effect is measured in microseconds, yet within those fractions of a heartbeat lies the evidence that the universe keeps its word. Elsewhere, massive detectors stand ready for events that happen once in a lifetime. When neutron stars collide, or black holes merge, they send gravitational waves that ripple across existence. Instruments like LIGO, Virgo, and CAGRA wait for these vibrations to brush through the Earth, stretching space by less than the width of an atomic nucleus. The detection of such waves is a conversation with the cosmos, one that confirms relativity not in theory, but in sound. Each recorded chirp is a greeting from a distant catastrophe, proof that space-time itself can carry music. Pulsar timing arrays extend this idea into an even larger key. These natural clocks, neutron stars, spinning hundreds of times per second, emit radio pulses so regular that they outlast human precision. By tracking them for years, astronomers can detect the faint rhythm of gravitational waves from colossal mergers billions of light-years away. Each subtle deviation in a pulsar's beat is a ripple passing through the galaxy. The universe reveals its scale through timing, and even the briefest pulse becomes a metronome for infinity. Not all experiments look outward. Some turn inward, to the atom itself. In quiet laboratories, physicists let clouds of ultra-cold atoms fall through vacuum chambers while measuring how they drift under gravity. These atom interferometers test whether all forms of matter and even energy fall the same way. So far, they do. But the precision grows finer each year, pushing deeper into the question, is gravity truly universal, or does it hide a subtle difference at quantum scales? Each test is an invitation for the laws of nature to surprise us, and each confirmation deepens our calm, for in the quiet regularity of the results, the universe seems content to be consistent. Far beyond the solar system, spacecraft like Voyager still whisper across the decades. Their radio signals, stretched by the expansion of space, carry data that verify how time and motion intertwine. Even their drift, the faint push of sunlight against their surfaces, becomes a test of gravity's reach. The cosmos measures itself through these messengers, and we, listening across light hours, learn that the rules hold steady even in interstellar silence. Through all these efforts, a larger pattern becomes clear. Every experiment, no matter how local, touches a universal rhythm. The bending of starlight, the delay of radio waves, the time drift of atomic clocks, the trembling of detectors all point to one truth. Light and gravity are inseparable expressions of the same geometry. The precision of measurement becomes a form of faith, not in doctrine, but in continuity. We keep asking the same question because the answer never stops being beautiful. There is also humility in this pursuit. Each success reveals not how much we know, but how vast the unknown remains. For every confirmation of relativity, there is a deeper mystery waiting: the quantum nature of gravity, the fate of information in black holes, the tension between smooth space-time and granular uncertainty. Yet even the unanswered questions offer peace, because they show that the universe still has more to teach. Mystery, after all, is a kind of grace. To those who watch the instruments, who sift through the data, the reward is not only discovery, but perspective. A tiny signal buried in noise can affirm a law that governs galaxies. A fraction of delay in a radio echo can reveal the mass of a planet. Science at this scale is not conquest, it is listening. Each experiment, like a meditation, refines our hearing, teaching us to perceive the faint correspondence between theory and reality. And so, the testing continues. Year after year, with sharper instruments and quieter rooms, humanity reaffirms its dialogue with the universe. Gravity still bends the same way. Light still obeys. Time still flows with deference to curvature. The constancy of these results does not breed boredom, it breeds wonder. To find the same truth echoed everywhere, from the orbit of satellites to the death of stars, is to glimpse the serenity beneath motion. The universe, it seems, does not need to shout to be heard. It speaks through precision, through delay, through the disciplined choreography of light and gravity. Every experiment is a new verse in that cosmic poem, a verification of harmony written across space and time. And as our instruments grow ever more sensitive, they will continue to translate that harmony into numbers, into waves, into calm understanding. At the quiet end of all exploration, a single realization waits that light and gravity are not rivals, not even separate. They are two syllables of one language, two gestures of one law. One reveals, the other shapes, one travels, the other guides. Together they form the geometry of existence, the slow pulse of a universe that bends yet never breaks. In their unity, there is peace, a sense that motion and stillness, brightness and weight belong to one continuous order. Imagine the universe without light, a silent architecture of pure curvature, invisible, mathematical, unseen. Imagine it without gravity, a chaotic flood of radiance, unanchored, without direction or focus. Only together do they make meaning. Gravity gives structure to light's endless travel, and light gives gravity visibility. The two weave the tapestry of reality, one thread radiant, the other invisible. Every star, every atom, every moment of awareness arises from their interplay. Without their conversation, there would be no color, no orbit, no sense of time. Their partnership begins everywhere at once, from the faint afterglow of the cosmic microwave background to the delicate curve of a planet's horizon. Light obeys the gentle persuasion of gravity. The same equations that describe the orbit of moons describe the path of a photon through space bent by a galaxy. The same curvature that holds oceans to Earth holds sunlight in a subtle arc as it rises and sets. This continuity is what gives the cosmos its coherence. It means that nothing, not matter, not energy, not time, exists apart from the whole. And yet, within that unity, there is movement. Gravity is patience, light is speed. One waits, one races, one anchors, one explores. The relationship between them is not a battle but a balance, a dialogue of extremes that together sustain the universe. In their harmony, we find a model for understanding ourselves, that rest and motion, weight and flight, are not contradictions but companions. The night sky, when viewed with awareness, becomes a lesson in coexistence. Every beam of starlight that reaches Earth has been sculpted by gravity's invisible hand. It arrives curved, delayed, sometimes magnified or reddened, but never lost. The universe bends its light, as a musician bends a note, not to distort it, but to give it depth. Each distortion carries information about the mass it passed, the space it crossed, the time it endured. Through these gentle alterations, light becomes a storyteller. It tells of galaxies colliding, of stars collapsing, of time itself stretching. Gravity, meanwhile, is the editor shaping the narrative, setting its rhythm, ensuring coherence between the first page and the last. When we listen to the universe through instruments, what we hear is not randomness but rhythm. The pulse of pulsars, the ringing of gravitational waves, the steady hum of background radiation, all are variations on the same theme. Each event echoes the geometry that unites energy with form. Every signal we detect, whether light or gravity, is a verse in a cosmic poem that has no author and no ending, only structure. At times, this unity appears in extremes: the ring of light around a black hole, where brightness outlines darkness in perfect symmetry. At other times, it appears in the ordinary: the slow drop of sunlight across a stone, the steady fall of an apple. Each is a small reminder that the universe does not separate grandeur from simplicity. The same principles that govern the curvature of galaxies govern the curve of a shadow on the ground. To see this is to understand that calm and vastness can coexist. There is humility in such awareness. It reveals that we are not outsiders peering into a distant cosmos, but participants within it. The light that reaches our eyes and the gravity that holds our bodies to Earth are the same forces at play among the stars. Every heartbeat, every step, is a local expression of the same law that bends galaxies and guides light across eternity. To feel that connection is to recognize that the cosmos is not elsewhere, it is here, folded into the present moment. The more deeply we study these forces, the more they blur into one. In modern physics, gravity and light are both waves on a deeper field, ripples of energy that obey the same fundamental symmetries. The photon and the graviton, if such a particle exists, are notes of the same chord. The quest to unite them into a single theory, a quantum gravity, a final equation, is not merely a search for mathematical completion. It is an attempt to articulate what the universe already knows, that all distinctions are temporary, and that harmony is the underlying condition of reality. When one steps outside on a clear night and looks upward, this truth becomes visible, not through calculation, but through quietness. The stars do not announce their physics, they demonstrate it. Light flows freely through the corridors of gravity, and the sky becomes an image of serenity drawn on an infinite scale. Even the faintest glimmer is a triumph of balance, a photon that has crossed eons of curved space-time without losing its purpose. That persistence is the essence of calm. To rest in this understanding is to see the universe as a single, continuous gesture, light tracing gravity's curve, gravity holding light's path. No part is wasted, no law forgotten. The cosmos is self-consistent, endlessly transforming yet never chaotic. It expands, but with grace. It evolves, but without haste. Each movement is the unfolding of a pattern written at the beginning of time, and every observer, every atom, every ray of light participates in that unfolding. The final comfort lies in knowing that this harmony is not fragile. It does not depend on our observation. Whether or not anyone looks upward, the stars continue to burn, photons continue to travel, and gravity continues to shape the invisible stage. The unity between them is eternal and self-sustaining. The night sky, therefore, is not just beautiful, it is proof that balance is woven into the foundation of reality. And so, the story returns to silence. The instruments rest, the telescopes close, the waves fade back into equilibrium. Light continues its unending voyage, and gravity continues its quiet sculpting. Together, they sustain the rhythm of existence, an eternal dialogue between speed and stillness, brightness and depth. The universe breathes through them, and through that breath, it offers peace. Night falls again, and the instruments sleep beneath their domes. The sky above them stretches, soft and endless, and the same light that began its journey billions of years ago still moves through the dark, still whispering across the curvature of time. Gravity holds it gently, shaping each beam into arcs of purpose, while the photons drift onward without fatigue. Together they create a serenity that no storm of thought can disturb. To stand beneath that sky is to feel what every equation seeks to express, that order and wonder are not separate things. The universe, for all its distance, is tender in its precision. Every orbit, every beam, every pause of time obeys a pattern that feels almost compassionate, a mathematics of calm. Even chaos has structure, and even the void carries warmth. Light, in its endless motion, teaches persistence. Gravity, in its unhurried strength, teaches patience. Between them lies a lesson too simple to require belief, that balance sustains everything. The cosmos does not demand attention, it simply continues, infinitely measured, infinitely serene. The stars we see tonight are ancient, but their messages are current. Each one says the same thing in its own wavelength, that there is harmony, and that harmony endures. And as we listen, we join that harmony not as spectators, but as part of the same luminous curve. So let the night stay quiet, let the equations rest. Light will go on tracing the arcs of gravity, and gravity will go on giving shape to light. In their union, the universe will remain what it has always been, a calm geometry of being, infinite and still, glowing softly through the long, slow breath of time.